Hey guys, the goal of this video is to make sure that you can understand how to find geometric probabilities. So first you have to understand what is the geometric setting. I want to just give you a friendly reminder, whether it's a binomial setting or a geometric setting, you do not need to check the conditions unless you are asked. You just have to recognize that this problem is a geometric setting or a binomial setting so you can figure out those probabilities. What is a geometric setting? It arises when we perform several independent trials of the same chance process and record the number of trials until a particular outcome occurs. The four conditions for those geometric settings, now we're going to have an acronym again, just like we did for binomial. For binomial, our acronym was BINS. That was to help us figure out if we have a binomial setting. Our acronym for geometric setting is BITS. Notice there's only one letter different between BINS and BITS. That means that they're pretty similar. Let's talk about this. B is the same. What does that stand for? Binary. It's a success or we have a failure. A success or a failure. Okay. Possible outcomes of each trial are success or failure. Independent. Trials are independent of each other. That's what we have right here. And again, I'll post these notes online. If you don't have the notes, you'll have to pause and write it down if you need to. Now, T is the only thing that's different. In BINS, N stood for the number of trials are fixed. T stands for time. Okay, look here. We perform several independent trials of the same chance process and record the number of trials until a particular outcome occurs. We are waiting a certain amount of time before we get a success. Here it is. Let's spend some more time for it. The goal is to count the number of trials until the first success occurs. If you're like, what the heck are you talking about? That's okay. We'll go through it. A basic one would just be if you have a free throw shooter. Shaquille O'Neal's at the free throw line. What's the probability that his first success will be on his fifth trial? So that means he fails on the first one, the second one, the third one, the fourth one, and on the fifth trial, he has his success. Okay? Fifth trial. What's the probability if we roll the dice? On the third roll, we get a 5. That means on the first roll, we don't get a 5. The second roll, we don't get a 5. But the third roll, we do. That's that wait time. And again, we'll spend some more time with this here in a second. As the same for binomial. On each trial, the probability of success must be the same. Okay, must be the same. Shaquille O'Neal, he's a free throw shooter. He has a long-term probability that's been established about his free throw that they say, hey, every time he goes up to the net, he has about a 53% chance of making that. Rolling dice, 1 out of 6 chance that we're going to get a 3 on one of those. Okay. Now, there's a formula for geometric probability. How do we figure out geometric probability? You do need to write this down. Okay, the probability that capital Y, that's the distribution. So what's the story about? We're going to roll, we're rolling dice or we're shooting free throws. Okay, that our first success is on K times. Okay, so that means Shaquille O'Neal, he's going to make his basket on the 5th time. That's what that K means. That's what we're looking for. 1 minus PP is equal to our probability of success. K minus 1 power times P. So let's write this down though. This K right here. This is the trial where we have our first success. Y is just the setting. We're shooting free throws, we're rolling dice, whatever the setting is. And then again, a friendly reminder that P is the probability of success. All right, there is a mean for a geometric random variable. To find the mean of a geometric random variable, you do, oh, I don't have it here, I'm sorry. That is 1 divided by P. Okay, so if you think about it this way, rolling dice can be a geometric random variable. We want to know, on average, how long are we going to have to wait until we get our first 3? Well, the probability of success of a 3 is 1 out of 6. 1 divided by 1/6 is equal to 6. So what we're saying is in the long run, On the 6th trial, on average, we should be able to get a 3, okay? So we roll 5 failures, and then on the 6th time, we should be able to get a 3. It makes sense. Oh, and then I have it right here. Sorry. The expected number of trials required to get the first success is equal to about 1 over p. You do not need to know the standard deviation for a geometric random variable. Okay, now that we've talked about a geometric random variable, what the setting is, let's spend some time actually doing some problems with it. You will be able to use your calculator with this as well, okay? So we're gonna go with this geometric distribution here. 6% of people have O negative blood. Let's talk about it in terms of bits. Binary. We either have O negative blood or we don't. Independent. The probability of my blood type is completely different than the probability. It's not dependent on anyone else's blood type in our class, right? It's all independent. Okay. T. Time. Sorry, I almost said W because we used to say W. Time. The probability, how long are we going to have to wait until our first success? Well, we can't see that quite yet because we haven't read the problem in blue. And then the probability of success, this is established that 6% of people have O negative blood. That is the same for everyone in the population. If I had 100 people in the room, 6 of them approximately should have O negative blood. Okay, so here's our first question, and this is what's going to tell us that we have a geometric setting and not a binomial setting. What is the probability that the first O negative person tested, or what is the probability that the first O negative person is the 4th person tested? So you can imagine we're working in a blood bank, right? Or blood drive. One person comes in, they're not O negative. Second person comes in, not O negative. Third person comes in, they're not O negative. The 4th person tests O negative. That's our success there. We were waiting until our first success. Maybe some of you at home are thinking, well, what would it be if it was binomial? Binomial would be, hey, what would be the probability if 10 people walked into the room, 1 of them had O negative or 4 of them had O negative? Fixed number of trials there. That's the difference. Okay, so let's go ahead and let's figure this out. You could say in our formula over here, I'll copy this over here so we have it. It says Y, you can say X too, it doesn't matter. Okay. So let's use that formula, okay, to start writing it out. So the probability, Y we can say, or X, I don't care, is equal to K. Remember we said that K was where is our first success going to occur? Well, that's that 4th person. Okay, that's that 4th person. So Y is equal to 4 is equal to 1 minus P. The probability is 6%, guys. People, we know we can't put percentages in the calculator. We do need to change those to decimals. So we move that decimal over 2 to the left, 0.06. To the K minus 1 power. I know you guys know that's 3. I just like to plug it in exactly how it is because sometimes I get people who come back to their notes and they're like, where'd you get the 3? Like they don't understand. So I want to keep that formula exactly. I want to like plug it in exactly how we see the formula. Times, right? 0.06. Now we could go ahead and we could type that in our calculator. This makes sense to you guys. When it's an equal to type of question, that is just, you know, multiplication rule. We have a failure, 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 and then we have a success. Now it does get a little more complicated. So we could just go ahead and we could type this in our calculator. But I also want to show you how to use a geometric PDF, Geom PDF. Okay, Geom PDF we can get from our calculator, guys, and that works for all things when we have Y is equal to K. Okay, whenever we have an equal to. So what we can do is we can go into our calculator for this problem and we can say the probability that capital Y equals 4 Okay, my son just came here. He can say hi since.
Hi. Where's my ice cream?
It's in your basket. Okay. All right. Sorry, guys. I can't find my pause button right now, and I'm too far into this to have to like redo it all. So the probability that Y is equal to 4. What I'm showing you right now is how to use the Geom PDF, not the Binom PDF like we learned before, but the Geom PDF. We're going to go to our graphing calculator. Okay. I'm going to go to second, vars. You can see the binom PDF and the binom CDF. PDF is for equals, CDF is for cumulative when we have an inequality. Right here, though, we have the geometric PDF. We're going to go right there and we're going to hit enter. If you have an older calculator, just sit tight. Our probability is 0.06. Our X value, or in this case, we put K. Our X value is 4. And then we're going to go ahead and paste. Now, those of you with the older calculator, you should see geom PDF and this parentheses there. Then just go ahead and put the probability first. The comma is right here. And then here, the number of trials that will, or the trial where we will see the first success goes there. And then close that parentheses, which is right there. Okay. So we're going to hit enter. And there we go. We have 0.0498. 0.0498. Now, if you want to use your calculator for a PDF, I'm totally fine with that. The biggest thing what the College Board will require is you need to put geom PDF 0.06, comma, 4, and then this is our P, and you can put K or X, it doesn't matter. Textbooks vary. All right, what will I require on a test? I want to see this statement right here, this probability statement. I do, if you're going to use geom PDF, I do need to see this geometric PDF. I need to see the P and the X or the P and the K, okay? And then obviously the correct answer there with 4 decimal places. All right, let's move on to the next one. What is the probability that the first O negative person, that's spelled wrong, that's embarrassing. Okay, I won't take the time to fix it right now though, will be found somewhere in the first 5 people tested. So what does that mean? I could find it in the first person tested, or the second person tested, or the third person tested, or the fourth person tested, or the 5th person tested. Somewhere, so again, you imagine you're working at a blood drive. First person, it could be that person, it could be the second one, the third one, the fourth one, or the 5th one. So what we could do, ladies and gentlemen, is we could do a binom PDF, a geom PDF, excuse me, a geom PDF for 1. So we would change this 4 to a 1, do it again for a 2, change it to a 2, do it again for a 3, change that to a 3 right there. We've already have the 4, and then change it to a 5. We could do that and we could add it all up. But this statement is the same as the probability of X being less than or equal to 5. And what's awesome about that is we can use now the geom CDF. The geom CDF always works for a probability that X is going to be, or Y. Again, we're just using a capital letter to describe the distribution. Less than or equal to K. I like using K because oftentimes we use X and I don't like using lowercase x. I feel like it confuses people. Okay, so our geom CDF will work for any of these situations. So I'm going to go ahead and I'm going to type that in my calculator, geom CDF. I guess, never mind, I'm going to write it down right here, and then I'll show you how to get it in your calculator. All right, so here we go. Calculator is right here. Second, vars, CDF. My probability is 0.06. My X value or K value, right, is 5. I hit paste. Those of you with the old calculator do 0.06. Your comma is right there. 5 is right here. Close the parentheses. We hit enter and we get 0.2661. Okay, so 0.06, comma 5 is equal to 0.2661, and we have P, and we have X. Again, what am I going to require on the test? This statement right here, your calculator speak with it labeled, and then your final answer. Okay, last one on this page. What is the chance we'll have to test at least 10 people before we find an O negative person? So what does that mean, ladies and gentlemen? At least 10 people before we find an O negative person. That means that the first person doesn't have it. The second person doesn't have it. You know, instead of typing, I'm just going to do numbers. The first person doesn't have it. The second person doesn't have it. Third, fourth, fifth, sixth, seventh, eighth, ninth, at least 10. That means the 10th person could have it. The 11th person is at least 10. The 12th person, dot, 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 on and on and on. These can be tricky for some people, but listen carefully. Okay. I know that the first 9 people cannot be O negative. That's our failure. Our success is O negative. Our failure is not having it. At least 10 and on and on and on goes this way, right? Well, how am I going to figure that out? First, let's write it as a probability statement. This right here, what I want right now, ladies and gentlemen, is I want the probability that X, our situation that we get our first success, is greater than or equal to 10. Okay, well, that's an issue. Why is that an issue? Our CDF will only work for it being less than or equal to 10. So what am I, or I'm sorry, not 10, less than or equal to a number. So anytime we have a greater than or equal to, we need to use the complement rule. I want to very firmly suggest, okay, with conviction here, anytime you have a greater than, or just anytime in general, it's a cumulative, write it out like we did here, or write it out like we did here, guys, okay? What do we want? What do we not want? Really helps when we have a greater than or equal to or a greater than. So I write it out 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have 10 or more is what I do want. I need to use the complement rule. I need to do 1 minus the probability of what I don't want. Well, I don't want 1 minus the probability that X is less than or equal to 9. And this will give me what I want. So what's nice about that now is look at this inequality now. This matches up with what we need for the CDF. So we're going to do 1 minus geom CDF 0.06 comma 9. Because that is our K value right there, or our X value. Okay, I'm going to put P, X, or PK. Again, I don't care. Let's go to my graphing calculator and let's do that together. So 1 minus geom, so second vars, CDF 0.06. We're going to change this to a 9. We are going to paste. And we have 0.5729, so 0.573. All right, I know it's getting along because you guys did binomial as well, but let's go ahead and let's look at the next one here. I think this is a good one. All right, the random variable of interest in this example is y is equal to the number of attempts it takes to roll doubles one time. Each attempt is one trial of the chance process. Let's check the conditions for a geometric setting. I'm not going to go ahead and check those conditions. I'm just going to tell you that they do work, okay? Problem, let the random, and I'm only doing that to save us some time. Let the random variable y be defined as the previous alternate example. That's this, example 22 right here. Find the probability that it takes 3 turns to roll doubles, okay? So the first thing that we need to do is we need to figure out the probability of rolling doubles. I don't know why I should just type. Okay, that's the first thing we have to do. So sometimes you have to figure out the probability, and that's what can be tricky sometimes, okay? But we should be okay. We need to first find the probability of rolling doubles, okay? Anytime you have 2 dice problems, make the grid. We can have a 1, 2, 3, 4, 5, and 6 with one of the dice, and 1, 2, 3, 4, 5, and 6. Where am I going to roll doubles? I'm going to roll doubles here. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. How many ways can I roll here? There are 36 total ways. So the probability of rolling doubles is 6 out of 36, which is a 1/6 chance. Okay, that's my probability of success. Okay, find the probability that it takes 3 turns to roll doubles. For part A now, we're going to write a probability statement. We always want to do that. The probability that X is equal to 3. Okay, because this is an equal to, this is a PDF. We're going to do a geometric PDF. Probability first, 1/6, comma, K, whatever this number is, the trial where we get our first success. So that's at 3. Okay, I'm going to go to my calculator. Second vars. I'm going to scroll up. I see that PDF because it's an equal to. That's why we want to always write that statement out. Probability is 1/6. X value is 3. We're going to paste 0.1157. We want to make sure that we put P and K or P and X right under it. Okay. Part B. Find the probability that it takes more than 3 turns to roll doubles and interpret this value in context. So X then is greater than 3. Okay. Anytime you have an inequality, again, write it out. Like I said, it takes more than 3. So we have 1. We're not going to get it on the first roll. We're not going to get it on the second roll. We're not going to get it on the third roll, but we could get it on the 4th, the 5th, the 6th, ... What do we want? We want 4 or more. What do we not want? 3 or less than that. So we need to rewrite this in terms of the probability of X being less than or equal to K, because our CDF, a cumulative, will only work for a less than. So I am going to rewrite this now using the complement rule. That's what we just talked about, you guys, on this problem. We said anytime we have an at least, we have to do the complement rule. Okay, so here we go. 1 minus what we don't want. And I use this smiley face here. Okay. 1 minus the probability of what we want. I hope my family can hear that I'm making a video right now because I can hear them. I'm so sorry, you guys. Let's finish this up. We do 1 minus the probability that X is less than or equal to 3. And we are good for the day, guys. Let's finish this up because I know I'm running out of time on my video. Geom, CDF, 1/6, comma 3. And I'm going to let you plug that in because, like I said, I am running out of time here and it's going to cut me off. Make sure you ask if you have any questions. These part can be a little tricky like the binomial, but hopefully if you watch the binomial, you feel good about that. It wasn't too difficult, but if it is, no problem. Just come to me. I am here to help. And thank you. Have a wonderful weekend and we will talk to you guys later.